Degree of parallelism, we can see it in actual plan. We couldn't see this in the estimated plan. And we can't always get actual plan, which is kind of a bummer. There are some cases where, we just can't run a query against the production environment that has the real data because it has too much impact on the environment, or it modifies data, or we just can't run against production. So in an estimated plan, we will not see what degree of parallelism. In an estimated plan, I will try to look at, okay, so what level of parallelism will this get? What do I think this is going to get? We can also see in some of SQL Server's dynamic management views, depending on our versions of SQL Server, but more info has been added into the DMVs as well as Query Store, which we'll see. We can see information about, okay, what was the DOP this got the last time it ran in some of these dynamic management views. So we could guess based on the cost of the query, as we'll see, and the configuration, okay, about how parallel will this be? And then we could also try to look for past executions. What DOP did it get? This is just screenshots of that thread reservation that we saw in this execution plan, which has 2 branches. When we were at degree of parallelism of 2, we reserved 4 threads, and we ended up using 3. We were able to reuse some threads. When we were at DOP 4, we reserved 6 threads. Or sorry, I am such a goober. This picture is, I have oh, no, I'm just reading it wrong. I apologize. I'm having a hard time reading the slide. So reserved threads is in 2 places here. So this is DOP 4. There are 8 threads reserved. 6 plus 2 equals 8, right? So I'm just not adding up my thread reservations properly. At DOP 6, we have 8 reserved threads plus 4 reserved threads equals 12 reserved threads. There's some simple arithmetic here that obviously I need a little more coffee to handle this morning. And then on this one we have, and notice that it didn't make these, we're going to talk more about NUMO. This is what these groups are, these are groups of logical processors in the NUMA node. So in NUMA node ID 0, we reserved 6 threads. In NUMA node ID 2, we reserved 10 threads. We actually only used 9 threads. Derp, derp, derp. There's a reason I named my VM derp, derp. So properly expanding them all, that is the number of threads. And the big takeaway from here is just higher DOPs, our queries can be faster, but there are trade-offs. And one of the trade-offs is we may burn more CPU time, depending, and we may use more threads. And if we have a lot of concurrent queries running at the same time going parallel, this could add up to a lot of threads. Some of these, the reason that it's reserving more threads than it's using is that it needs to make sure it can do everything. And some of this is based on timing. Some of these threads were able to be reused because parts of the plan completed and freed that thread up. And then it said, oh, instead of going and using another thread, I could just reuse this thread to do some work. That is fairly normal. There might be times when this runs where something changes and maybe blocking happens and it prevents it from reusing the threads, right? So it's reserving these threads because it may need them all, but it is, SQL Server is efficient about saying, oh, if that thread's done with its work, I can have it do something else. And the SQL Server OS inside SQL Server helps figure out, okay, I'm going to coordinate all this work on the threads. All right, recapping our settings. The instance level MAXDOP. It is definitely a best practice to always set your instance level MAXDOP simply because the default setting for this is no bueno. It is very rare for the best parallelism setting to be all logical processors up to 64. Whether it's a very small virtual machine or whether it's a large virtual machine, typically just saying, hey, use all the cores if you go parallel isn't the best choice. It can happen sometimes, but you want to think about it. And even if, let's say I have a 16 core VM and I do want to set MAXDOP to 16 because I've tested and that's right for my workload, I would still rather set MAXDOP to 16 rather than 0 just to make it clear that it was done on purpose, right? Someone actually set this rather than just leaving it with the factory default setting there. MAXDOP 1 means no parallel queries. Now this can actually be overridden. We'll look at forcing parallelism later on. There are ways that you can hint a lot of different things. a clever user could force parallelism even when you've said the degree of parallelism is 1. In other words, no parallelism. MAXDOP of 1, some people say is an anti-pattern. Even that isn't always an anti-pattern. There are some applications, the most famous of which is SharePoint, but some applications are written and tested to run in a single-threaded mode. And if the installation instructions say, hey, you should run this under MAXDOP 1, it's designed for everything to be single-threaded, that's how it's tested. That's how it's supposed to perform best. So we need to follow that. Typically, if the application isn't rigorously tested to be all single-threaded, typically we don't want to do that. But we can't say it's a bad practice because there, in fact, are some applications engineered to be the best single-threaded, and that is what those applications like to do. If we set, let's say I have 10 cores, and let's go ahead and demo this one. Let's go ahead and set our max degree of parallelism to higher than what we actually have. If we switch back into derp here, I am going to set MAXDOP 64 and run that as a hint, and I'm going to execute my query. I don't have 64 cores, I have 10 cores. SQL Server says, cool story, bro. Like, it does run my query. It does run my query, but it says I can only use what you've got. There are some undocumented, I believe it's a startup flag. Like, there is a way you can actually configure your SQL Server to see more cores than there actually are on the Windows instance, or I guess you can run it on Linux now too. You can hack SQL Server in an undocumented way. I forget exactly what the procedure is, but it's on the internet, to see more cores than the operating system gives it. You are not given any, I would expect that you might have terrible performance and things might crash. The only reason I know that people would do that is for crazy demos. So I would never recommend that in reality, but that it is possible to get a higher MAXDOP than the cores you have, but not just by hinting. If we hint and we don't have it, it goes with what we have, which I think is a good thing, right? Like, I shouldn't try to use cores that I don't have. That would just be kind of crazy. For those database level settings, it will override the instance setting. And if you think this might be set, check through the database scoped configuration DMV. Of course, we do have to check that for every single database on the instance because it's database level. Resource Governor, it is 2008 plus. It is only Enterprise Edition, even after 2016. This is sort of my last resort. It's mostly used for, legacy apps where we can't change the code and we have to kind of put some duct tape on it. So I would see classifying MAXDOP as sort of duct taping a fix in if we don't have other options. And one of the biggest reasons, and not only is it the complexity that I'm not a fan of, but also the fact that making a query run at a DOP that it wasn't optimized for is really weird. Now, also know that, let's say I set Resource Governor for DOP 6. It's not going to force things to be parallel. If a query is classified and it doesn't qualify to go parallel, it's not forced to get DOP 6. It's only if it goes parallel that DOP is applied at execution time. If you change your Resource Governor setting to make it take effect, you do have to run the Resource Governor reconfigure, not the instance level reconfigure. So if you find it in place and you want to change it, you have to reconfigure to see the change. Query hints, option MAXDOP number. Again, these will not force parallelism. If the query qualifies for parallelism, this is the parallelism they can get, but we are not guaranteeing that the query will go parallel. We are at least talking to the SQL Server optimizer, right? So it will optimize the query. Like, if the query qualifies for parallel, we don't have something inhibiting parallelism and it's above the threshold we're going to talk about. The optimizer will optimize for this parallelism. It is still true that when parallel queries are executing on your SQL Server, there are ways that if there's a lot of pressure on your SQL Server and things are executing, it actually can, in some cases, reduce the parallelism at execution time. Not the optimizer, but the engine can reduce the parallelism at execution time. It's fairly rare to see, and it's kind of difficult to observe, but technically that can happen. If you cannot change the code, like, oh, I don't want to change the DOP for the whole instance, and I don't want to hassle with resource governor, either because I don't have enterprise edition or because it's just so freaking complicated. You can use plan guides to apply a query hint. You can set up a plan guide that says when you see this text, you can say whether or not it's part of a stored procedure. When you see this text, I want you to tack on a hint, and you can tack on a MAXDOP hint. That is actually kind of a cool thing about query hints if you just want to change the degree of parallelism for a few queries that need help and you can't change the code. It is not always pleasant to wrangle with plan guides. I fully admit that. It's kind of one of those things where you're like, I have to struggle a lot to get it to work, and sometimes it just won't work, but it is an option. I won't say that it's a pleasant option, but sometimes we don't have a lot of other good choices if it's a vendor application or a legacy application. Will a vendor be happy about you using plan guides? Maybe, maybe not. It's worth checking and seeing if there's a better way to fix it. All right, and this is the slide that I need to change because this slide goes over DOP competitions, who wins, and this one should be min resource database query hint. So this is the one, and it's my mistake continues on to the next slide. As we saw in testing today, if we have set the instance DOP, the database DOP, the resource governor DOP, and the query hint DOP, the min of resource governor, database, and query hint will win. Whew. So things are simpler. The top rows are how the rules work if we don't have resource governor involved. And typically query hint will win if resource governor isn't involved and we do have query hint set. Query hint will win. If we just have database and instance set, database will win. If we have resource governor and database, the minimum will win. Same with the query hint. So we can underride, the gist is when resource governor is involved, we can underride resource governor, but not override resource governor. And this is based on an older post by Jack Lee, who's part of the Microsoft team. He wrote the post before we had the database level options. So on the next slide, I also need to change that because this should say database as well. This is one of the things that has changed. And there we go. So I will republish the PDFs as well. And I'm going to recheck it after the seminar to make sure I'm consistently seeing the same thing. I'm not surprised totally that I got confused with this. I did actually try to test it twice. So we have a question. I have a SharePoint system where MAXDOP set at 1, but I have 8 vCPUs. So I tried to set MAXDOP to a higher value in OLA's maintenance solution for DVCCs, but it didn't make any difference to the times. Is it normal? I see. So you're running by DVCCs, do you mean the CheckDBs that it's running? Sometimes, there are, and I think that's the only, okay, so yes, it is quite, I wouldn't be too surprised that in some cases, CheckDB might not be faster when it's parallel. What edition of SQL Server are you running to? Parallelism edition. I am trying to recall, and I think Aaron wrote about this. This is the Aaron's post here. There was a mix up in the documentation about this as part of why it's confusing. Okay, so you are running enterprise. So this is, she found, Aaron Stellato found an error in documentation where DBCC does not perform parallel checking of objects in standard edition. You have enterprise edition. So for enterprise edition, CheckDB represents the maximum degree of parallelism configured for the instance. This was before she wrote this post before we got the ability for CheckDB to take the option. So you're running SQL Server 2014 Enterprise, DBCC CheckDB. Now I want to look at the DBCC CheckDB options that when it got the MAXDOP hint. So I want to go down and look at, this is totally simple to figure out. Okay, so the MAXDOP option, so I was wondering if OLA's solution took the MAXDOP option but didn't always apply it based on your version. So do you have SP2 on your SQL Server 2014? So as of SQL Server 2014, SP2 and higher, the MAXDOP hint will work. Honestly, even if you have SP2 or higher, I wouldn't be too surprised if CheckDB is still somewhat, it's not always going to be faster with multiple cores, unfortunately, just depending on how it can do the checks. Okay, so it sounds like you are over service pack 2. So in theory, it should be working. You could, if you wanted to check, is it actually using parallelism, you should be able to see, I believe in that version, we'll double check. I believe you should be able to see the degree of parallelism the queries are using in sys.dm exec query stats. Let's see when we got those columns in there. We do have a demo coming up with query stats, but I'm running against 2017. So what I want to know from query stats is there should be total DOP. You won't be able to see these because these came in, our DOP columns in there came in SQL Server 2016 and higher. Curses. There are other ways you could observe this. You could run SP who is active while it's running and kind of look at its thread usage. I believe it would be kicking in for you, but I'm not super shocked that it wouldn't be all that much faster. I mean, it's disappointing, but I'm not super shocked. Womp, womp, womp. Sadness. Where CheckDB has an impact and is creating problems on the server, one of the things I've done is just automated restores to another instance and run CheckDB against the restored databases. The benefits of this are that you check your restores. You always know that your restores are working, and CheckDB has no impact on your primary instance. The downside is that this is a licensing gray area. Does running CheckDB against the data qualify as a production use of the data? It's a little unclear. What if that instance that I'm restoring to and running the CheckDB, what if I then clean the data and it's used for developer purposes? I could argue that I'm just making sure that my developer environment doesn't have corruption. Well, that depending on who your legal advisor is, right? Do I have to license that for production or not? It's kind of squishy. If I'm only using that instance for the purpose of checking corruption for my production database, then that does seem like a more production use. But that's why I say it's a gray area. Is it's kind of like, well, depending on how I'm going to use the data in that environment, I might be able to argue that it doesn't need an enterprise license, but I probably want to talk to whoever pays for my licenses and make sure they're real comfortable with whatever argument I'm making and make sure they sign off on that, because, you don't want to get caught in an audit and have a really expensive result come out of that. But yeah, offloading CheckDB is my favorite way to not have to care about how long CheckDB takes. I also measured for the same sample query that we looked at. I just measured duration and CPU usage for it when run it at different DOPs. So when using all 10 cores, the duration was right. We kind of have a little leveling off here of like, okay, and there's variation. This is not a super scientific measurement. There's going to be fluctuations of the same query run over and over again. It's going to be higher and lower just depending on is window update checking for updates in the background or whatnot. But we can see that, there is kind of a leveling off of performance here from, MAXDOP 6, 7-ish to MAXDOP 10. It's getting faster, but it's not all that much faster. But my CPU time is continuing to go up quite a bit. But at MAXDOP 1, I mean, this query is significantly slower at MAXDOP 1, where my CPU time is equal to my duration. I mean, the change in performance, the change in duration between MAXDOP 1 and just using 2 of my cores is really striking. And of course, the faster my cores are, the better and faster that my CPU cores are, the more impressive it's going to be at fewer cores. So since we pay so much for licensing SQL Server, it really makes sense to invest in fast processors because we want to get the most use for that licensing dollar. The faster the processor, the fewer cores I'm going to need to use to get a really good runtime. Now, of course, we can beat this from MAXDOP 2. It is in this one, it's kind of, I have had this in older versions of SQL Server and on older processors. Sometimes I have been able to see a pattern where the odd numbers were slower. That pattern is not happening here, right? We still see a gradual decrease in duration as well as an increase in CPU time as we go up here. It's less common to see poor performance from odd degrees of parallelisms these days. It is rare to use an odd DOP. Like, a lot of us who've been around and been configuring this since the old days tend to use even degrees of parallelism, the exception being 1 is obviously not an even number, and sometimes we need to use it for SharePoint, but sometimes it is different. In terms of the CheckDB, there is another factor that plays into this that we're going to look at in the next module, and that is cost. Even CheckDB, even with built-in queries in SQL Server, they have to qualify to go parallel. So whether or not your CheckDB is going parallel is also going to depend on where you have your cost threshold set and how CheckDB is estimating the cost for those queries. So it is, depending on what you have set on the instance, there is actually another reason why it might not be going parallel. And we will dig into that in the next module. Such a simple topic. Like, sometimes folks will want like a session on configuring MAXDOP in an hour, and I'm like, well, I could gloss over everything and do it in an hour, but there's just so much going on. Common practices. Common practice is to use spconfigure to change MAXDOP from that default value of 0. Even if you've got 8 cores and you want to run at MAXDOP 8, I would still say configure it to MAXDOP 8, just to be clear that this has been a decision made. I would also typically avoid using MAXDOP 1 unless the app was specially designed for that, or unless you're going to specially tune for that. If you are going to say nobody gets to go parallel, you may need to take care of some queries who are slow, either by tuning them so that they work well at MAXDOP 1, or by doing something else so that they can still go parallel. So if you're going to use MAXDOP 1 and the application isn't rigorously tested for that, you get to do the rigorous testing for that. Another common practice, and I would say it's wise to use query hints sparingly, because, I mean, and I'm not against these query hints, but it's simply that if it works well today to apply a query hint for something, that is kind of specific to my hardware and my particular processor speeds. If something is the sweet spot for something to run is MAXDOP 6 today, and I put a query hint in there, that could work well for a while, but maybe down the road, the sweet spot for it is actually MAXDOP 4 because I have newer, faster processors. Well, I'm going to actually have to go in and change all the individual query hints in that case, which is kind of a bummer. So if there's another way to do it that is easier, that's a more general setting, like a database setting or an instance setting, I would rather set it there just because I have less work ahead. Like, I'm not going to have as much flexibility if I have to go in and change a bunch of individual query hints and redeploy that code. Just could be kind of a pain. But still, they can be very useful, and sometimes they are the best option. I would rather do a query hint than resource governor for sure, right? Because it is going to be simpler to manage the query hint rather than resource governor. Whenever we're changing MAXDOP or cost threshold, which we're going to talk about next, we are going to cause our current query plans to not be considered valid. And I actually think this is fair because, okay, my queries were running with MAXDOP 4. I actually think it's if I change my MAXDOP at the instance level, and this slide should say, let's be clear here, if I change this at the instance level. So it's hard to get used to the fact that we can change this at the database level. Changing it at the database level, setting that scope is less invasive. But if I run it with a lot of different things, if you run spconfigure, running spconfigure, not for everything. It's interesting. There's not a complete documented map, but for a lot of things in the SQL Server, including things like memory limits or max server memory, we will have to generate new execution plans for everyone the next time they run. Oftentimes, it's not a big deal to flush the plan cache in production, but if you have a lot of concurrency and you're going to have a lot of people compile their queries at once, it can cause a CPU spike. If you've got some very parameter-sensitive queries who sometimes compile a bad plan when a specific parameter value is in there, they could happen to get that bad plan after you clear the plan cache. The same thing could happen after any failover or restart, though. So that's going to be a problem no matter what. But it's just good to be aware of that. Depending on the level you change this at, it is going to flush the plan cache. So Q&A and discussion. Can you override resource governor DOP? The way I think of this is I can underride resource governor's DOP. I cannot override resource governor's DOP. This question, are odd degrees of parallelism bad? On older versions of SQL Server and older hardware, there were some tests done that found that odd numbers of odd DOPs like 5, 7, 9, etc. would perform slower than the even lower DOP. So in other words, 7 would be slower than 6. The post I really know about that dove into this, a fellow named Lynchy Shea. Lynchy Shea? I'm not sure how to say his last name. Great blogger from the way back days in SQL Server. He had documented this on some of his servers. I think he worked for a large bank. Not sure if he still does. But I have not been able to see that on recent versions of SQL Server. I mean, this was back in like the 2005 days. So not recent. On recent versions of SQL Server, I have not seen the same problems with odd number stops. I typically do set it to an even value just because of old DBA superstition. Is that a valid reason? Is old DBA superstition a really valid reason to avoid odd DOPs? Probably not a valid reason. And then we have next this cost threshold value. So one of the things that might be happening with this CheckDB, we're using a hint and we're using an addition and version of SQL Server that should be capable of going parallel, but maybe it is going parallel, maybe it isn't. One of the things that can influence that is this threshold for parallelism. We have 2 dials when it comes to parallelism in SQL Server, and they're both really important. I've up until recently, I used to think of cost threshold as a fine-tuning dial. I have really changed my opinion, and these are both really significant controls for parallelism. Cost threshold helps control, it's not the only thing, but it helps control who goes parallel. MAXDOP says, if you go parallel, how many cores will you use? And it is how many cores will you use? As we've seen, even if I'm using 2 cores, I may use more threads. If I'm using 8 cores, I may use more threads, but those threads are going to stay on those same DOP number of cores. So I can really control my CPU usage by both of these dials because I may have some really inexpensive queries who go parallel, but they're just as fast if they don't go parallel, right? They are either the same speed or very, very close to the same speed. And as our processors that we use with SQL Server get faster and faster, this is more and more common for a single processor to be able to do amazing work. So by raising my cost threshold and saying not as many queries need to go parallel, I can limit how much CPU is being used, which really important towards licensing. By configuring my degree of parallelism to say, when you go parallel, how many cores do you use? And indirectly, how many threads might you use? Depending on the complexity of the query, it could be a lot. I can say, okay, you get to use only 4 cores when you go parallel, and that may be, for most of our queries, be fast enough, because as we use more cores, the benefit may either taper off or our performance may start going down. So I actually like to often tune cost threshold before I finalize my MAXDOP number. And what we're going to talk about next is how cost threshold works. We've been going for about 90 minutes now. So let's go ahead. It's 33 past. Let's go ahead and take a 7-minute break.